somewhere in the basement storage of the Louvre in Paris, and in cases at the National Museum of Iran in Tehran, and in scholarly archives across Europe and the Middle East, there are inscriptions in an ancient writing system that nobody alive could read for almost 120 years after the first examples were discovered. The symbols are geometric, precise, clearly systematic, scratched and carved onto stone, clay, and silver by people who knew exactly what they were writing and believed it mattered enough to preserve permanently. For more than a century after French archaeologists first dug them up from the ruins of Susa in southwestern Iran in 1903, they sat in complete silence. Nobody could hear what they said. Not because the inscriptions were damaged or incomplete, but because the script that encoded them, a writing system now called linear Elamite, had been used for a few hundred years in a powerful Bronze Age kingdom called Elam, then abandoned, superseded, and so thoroughly forgotten that by the time anyone tried to read it again, every person who had ever known how to do so had been dead for roughly 4,000 years. Then, in 2022, a French archaeologist named François Decode published a paper in one of the most respected Assyriology journals in the world, the Zeitschrift für Archaeologie und Vorderasiatische Archäologie, claiming something that his colleagues had genuinely not expected to see in their professional lifetimes, a decipherment. Not a partial reading, not a speculative hypothesis, but a systematic identification of the phonetic values of 72 signs in the linear Elamite script, covering over 95% of all sign occurrences in the known corpus of inscriptions. One of the last major undeciphered scripts in the world had been cracked, and the breakthrough came not from a lucky find of a bilingual inscription like the Rosetta Stone, not from a technological revelation, but from a set of silver vessels in a private collection in London and nearly 30 years of obsessive, meticulous scholarly work by a man who refused to accept that the silence was permanent. To understand why this matters so much and why deciphering an ancient script is genuinely one of the most profound intellectual achievements in the history of scholarship, you have to understand what exactly is lost when a writing system disappears and nobody can read it anymore. It isn't just vocabulary. It isn't just grammar. What's lost is the entire interior world of a civilization, everything they chose to record, their laws, their religious beliefs, their royal histories, their business transactions, their literature, their personal letters, all of it sitting in physical form, perfectly preserved in some cases by the durability of stone and fired clay, and completely inaccessible, sealed behind a cipher whose key has been missing for thousands of years. Reading a lost script for the first time isn't just translation, it's resurrection. The voice of a civilization that had been literally silent suddenly speaks again, and what it says is almost never what you expected. Elam was one of the oldest and most powerful civilizations of the ancient Near East, a contemporary and rival of Mesopotamia whose history spanned several thousand years and whose territory covered much of what is now southwestern and central Iran. It's a civilization that most educated people in the modern world couldn't name, because the filter of what's historically remembered tends strongly toward the civilizations whose records survived in readable form. We know an enormous amount about ancient Mesopotamia because cuneiform was deciphered in the 19th century and hundreds of thousands of tablets have since been translated. We know a great deal about ancient Egypt because Champollion cracked hieroglyphics in 1822. Elam, which interacted constantly and sometimes violently with both of these civilizations, which developed its own independent writing tradition and its own sophisticated political and religious culture, has remained a shadowy presence in ancient Near Eastern history, partly because its primary indigenous script was unreadable, meaning everything we knew about Elam came largely through the records of its neighbors, who weren't always neutral observers. The story of how Dest broke through that silence is worth telling in detail, because it illustrates the actual process of ancient script decipherment in a way that makes clear both how extraordinarily difficult it is and how the crucial turning points tend to come from unexpected directions rather than steady accumulation of effort. Deset began his career studying ancient Iran in the early 2000s, and the problem of linear Elamite became his primary obsession over the following decade and a half of fieldwork and archival research. By 2018, the total number of scholars who had successfully identified any phonetic values in linear Elamite was essentially zero in any robust sense, despite more than a century of sporadic attempts by some of the most capable linguists and philologists in the field. The script had defeated everyone who tried, largely because of a problem that haunts all undeciphered scripts, and that makes linear Elamite an almost maximally difficult case. The corpus is tiny. While cuneiform survives in hundreds of thousands of tablets, providing the statistical redundancy needed to identify patterns and meanings, linear Elamite survives in roughly 40 inscriptions, most of them short, found across a handful of sites in Iran. That's it. 40 inscriptions, representing the entire known written output of an indigenous Iranian script tradition that was used for hundreds of years across a civilization of considerable political and cultural sophistication. The breakthrough, when it finally came, arrived in a form that illustrates a pattern repeated in the history of script decipherment. a bilingual text, or something that functions like one. In 2018, Decode gained access to a set of silver vessels held in a private collection in London. These vessels, probably looted from an unexcavated site in Iran at some point in the 20th century, had something on them that immediately caught his attention. Some were inscribed in linear Elamite. Others, or in some cases the same vessels, were inscribed in a parallel text in cuneiform, the well-understood Mesopotamian script that had already been deciphered. The juxtaposition was what Decode later described as the jackpot. If the same text or closely related texts appeared in both scripts, and if one of the scripts was already readable, then the known text could serve as a key to begin identifying what the unknown symbols represented. Exactly the principle that had unlocked hieroglyphics through the Rosetta Stone almost 2 centuries earlier. What Decode found on those vessels were royal names, names of Elamite kings whose cuneiform spellings were already known from other sources, appearing in parallel in linear Elamite. By identifying which cluster of linear Elamite signs corresponded to the known phonetic spelling of a name like Shilhaha, an Elamite ruler from around 1950 BCE documented in cuneiform records, Decode could begin assigning phonetic values to individual signs, then test those values against other occurrences of the same signs in other inscriptions, refining and expanding the set of confirmed readings as the internal consistency of the decipherment proved itself out. It took several more years of painstaking work before the 2022 publication, work involving 5 co-authors with expertise spanning Elamite linguistics, Assyriology, and Iranian archaeology, cross-checking every proposed sign value against every available inscription to ensure the decipherment held up across the entire known corpus, rather than just fitting the initial bilingual examples. But by the time the paper appeared in print, its authors could claim, with documented evidence, that linear Elamite was primarily a phonographic, syllabic script, that its signs represented sounds rather than concepts, and that those sound values were now known for the overwhelming majority of signs in the corpus. Several scholars not involved in the research, when interviewed by publications, including the Smithsonian Magazine, expressed genuine conviction in the decipherment's validity, even while noting that some details continued to be refined. What the deciphered inscriptions actually say is itself a significant piece of the story, because the content is both more and less dramatic than the long silence might lead you to expect, in equal measure. The linear Elamite corpus, being royal in origin, consists overwhelmingly of commemorative and dedicatory inscriptions, kings recording their names, titles, lineages, and the religious acts they performed on behalf of their deities. This is historically valuable precisely because it's entirely indigenous, not filtered through Mesopotamian records or anyone else's diplomatic correspondence, but the direct self-representation of Elamite kings in their own script and their own language. Scholars can now read these inscriptions as the people who wrote them intended them to be read, understanding which king is speaking, which god is being invoked, which building or offering is being commemorated for the first time in 4,000 years. The content is not the dramatic revelation of forgotten secrets in any sensationalized sense. It's something more mundane and more profound simultaneously. The actual unmediated voice of a major ancient civilization finally becoming audible after millennia of silence. The linear Elamite decipherment also has significant implications for understanding the broader history of writing itself, because one of Decode's more controversial arguments concerns what kind of script linear Elamite actually is. His analysis argues that it's primarily phonographic, meaning its signs represent sounds rather than a mix of sounds and meaning-bearing symbols, as many earlier researchers assumed. If this reading holds up under continued scholarly scrutiny, it would make linear Elamite potentially the world's oldest primarily phonographic script, predating even the fully developed alphabetic scripts that emerged later in the ancient Near East and Levant, which challenges some existing models of how the transition from logographic to phonographic writing happened in the ancient world and how independently different early civilizations arrived at similar writing solutions. Now enter artificial intelligence, and specifically the role it is actually playing in this field right now, as opposed to the exaggerated claims that circulate constantly in popular content about AI single-handedly decoding ancient scripts with no human involvement. The reality is more interesting than the fiction and considerably more honest about both what these tools can and cannot do. At MIT's Computer Science and Artificial Intelligence Laboratory, researchers led by Professor Regina Barzilay have developed machine learning systems specifically designed to assist with the analysis of ancient and lost languages. Their approach exploits a principle that historical linguists have established over 2 centuries of comparative work. Languages evolve in predictable, constrained ways. Sounds shift according to patterns rather than randomly, certain substitutions being far more likely than others based on articulatory relationships between sounds. And related languages retain structural and vocabulary similarities that reflect their common ancestry. By training machine learning models on known patterns of language change and sound correspondence across large numbers of documented languages, these systems can, in principle, identify likely relationships between an unknown script and known languages, and make probabilistic suggestions about what unknown signs might represent if the unknown language is related to any language the model has learned. The MIT team demonstrated their system's capabilities on a genuinely impressive test case. They applied it to Linear B, the ancient Mycenaean Greek script that was itself undeciphered until the early 1950s, withholding the known decipherment and asking the system to work from scratch, with access only to the structural patterns of the script and the known relationships between Greek and other Indo-European languages. The system correctly identified Linear B's relationship to Greek, one of the key insights that had enabled the actual human decipherment by architect Michael Ventris in 1952, and recovered a substantial portion of the vocabulary. When applied to ancient Ugaritic, another script where the decipherment is known, the system performed comparably well. In a more recent application, MIT and Google DeepMind researchers tested AI tools against Linear B texts and achieved approximately 60% accuracy on sign-to-sound mapping when the system was primed with the knowledge that the script encoded an ancestor of ancient Greek. That 60% figure is worth sitting with, honestly, because it illustrates both the genuine capability of these systems and the genuine limitation. 60% accuracy on a script where the answer is already known, and where the system has the enormous advantage of knowing which language family to look in, is impressive as a proof of concept, but nowhere near sufficient for genuine decipherment of a truly unknown script. And the limitation identified by Decode himself when asked directly about AI's role in his own linear Elamite work is precisely the one that matters most. AI systems, he has said, excel at pattern recognition and at comparing a script to other members of the same linguistic family. What they currently cannot do is the creative, intuition-driven leap that characterizes the crucial moments in every successful human decipherment. The moment when Decode saw the silver vessels and recognized the bilingual opportunity they represented was not a pattern-matching insight. It was a flash of scholarly judgment shaped by decades of immersion in the material about where the key might be hidden. That kind of insight isn't currently something computational tools can generate independently. What AI can do, and is doing productively right now across multiple undeciphered script projects, is dramatically accelerate the supporting work that surrounds and enables human insight. For the Indus Valley script, one of the most stubbornly resistant undeciphered writing systems in the world, with roughly 4,000 known inscriptions on small seals and objects from a Bronze Age civilization in what is now Pakistan and northwestern India, AI tools have been used to exhaustively map the structural properties of the script, identifying all sign types, calculating the statistical distribution and co-occurrence patterns of signs, detecting the syntactic positions where different sign categories tend to appear, and comparing these structural fingerprints against the known properties of different types of writing systems, logographic, syllabic, alphabetic, to constrain the space of what the Indus script might be. This work doesn't produce a translation, but it rules out entire categories of hypotheses about the script's nature, helping researchers focus their efforts on more promising directions and avoid repeating failed approaches that the statistical analysis shows are incompatible with the script's actual structure. For Linear A, the undeciphered script of the Minoan civilization of Bronze Age Crete that preceded and partially influenced the later Linear B that Ventris decoded, AI-assisted analysis has made genuine progress in extracting structural information despite the enormous obstacle that Minoan, the language Linear A encodes, appears to be an isolated language with no known relatives, meaning the comparative linguistic approach that works so powerfully for scripts encoding languages related to known families provides almost no traction here. Researchers have used the SIG-LA digital database of Linear A sign occurrences to train pattern recognition systems that can identify clusters of signs likely functioning as specific grammatical categories, identify probable word boundaries in uncemented texts, and map the functional positions of specific signs in ways that begin to reveal the grammar's skeleton even without knowing the phonetic values of individual signs. Full translation of Linear A remains distant, but the structural map is becoming measurably clearer than it was a decade ago, and AI tools for organizing and analyzing the database have been central to that progress. Mayan hieroglyphics offer a particularly instructive historical parallel for understanding where AI assistance fits into the decipherment process, because the Mayan story involves a genuine decipherment that happened primarily through human scholarship across the 20th century, but that was also delayed for decades by a fundamentally wrong assumption that AI pattern analysis might have helped correct earlier. For much of the 20th century, a dominant school of thought held that Mayan glyphs were primarily logographic, with each symbol representing a word or concept rather than a sound or syllable. This assumption, maintained partly through institutional authority and partly through genuine uncertainty about a complex and unfamiliar writing system, actively blocked progress for years by leading researchers away from phonetic approaches that would eventually prove central to the decipherment. Work by Yuri Konrozov, beginning in the 1950s, combined with the contributions of Tatiana Proskuryakov, and later a generation of epigraphers in the 1970s through 1990s, gradually established that Mayan writing is a mixed system, using both phonetic syllable signs and logograms in combination, and that the phonetic component provides the keys to reading the vast majority of texts. By the late 20th century, researchers could read the great majority of surviving Mayan inscriptions, and the historical content of those inscriptions, dynastic histories, warfare records, astronomical observations, calendrical calculations, completely transformed understanding of classics. Maya civilization, revealing a political world of competing city-states, alliances, conquests, and cultural achievement, far more complex than the peaceful astronomer-priests that earlier pre-decipherment scholarship had imagined. The lesson of Mayan decipherment for understanding where AI fits in this broader history is specific. The breakthrough came from a correct identification of the script's structural nature, recognizing that it was mixed phonetic logographic rather than purely one or the other, combined with identifying the specific phonetic correspondences between signs and sounds. AI pattern analysis, had it been available in the 1950s and trained on the structural properties of known writing systems across different types, might plausibly have identified earlier that Mayan statistical fingerprint matched mixed systems more closely than purely logographic ones, potentially helping to orient human scholars toward the productive approach sooner. The creative insight would still have required a human mind immersed in the material. The computational support could have helped point it in the right direction faster. That's the most accurate and honest description of what the relationship between artificial intelligence and ancient script decipherment actually looks like right now. Not AI autonomously cracking codes that defeated human scholars for thousands of years, but AI functioning as an extraordinarily powerful analytical support tool, able to process and find patterns in datasets of a scale and complexity no individual human researcher could manage, reducing the space of possible hypotheses that need to be tested by human judgment, and accelerating the preliminary structural work that creates the conditions within which genuine decipherment insight becomes possible. The actual breakthrough moments in the history of script decipherment, from Champollion's hieroglyphics to Ventress's linear B to Decette's linear Elamite, have all involved human scholars making creative leaps from incomplete information, drawing on intuitions shaped by deep expertise, and recognizing the significance of a specific piece of evidence that unlocked everything else. That kind of creative scholarship is what no AI system can yet replicate, and honest researchers in both computational linguistics and ancient language studies are clear and consistent about this limitation in their own published work and public statements. What makes the current moment genuinely exciting, rather than overhyped, is the combination of three things happening simultaneously that has never existed before. The digitization of ancient text corpora, from cuneiform to hieroglyphics to linear B to the Indus script, has created structured, machine-accessible databases of a completeness and quality that didn't exist even 15 years ago. AI tools trained on these databases and on the broader comparative record of human language change are becoming measurably more powerful at the specific pattern recognition tasks that support decipherment work. And a generation of researchers who are simultaneously expert in ancient languages and computationally sophisticated is emerging. People who can design the right questions for AI tools to answer and interpret their results with the deep scholarly judgment those results require. The undeciphered scripts that remain, Linear A, the Indus script, Proto-Elamite, the Phaistos disc, the Rongorongo script of Easter Island, will not necessarily yield to this combination of tools and expertise, because some of them may present obstacles, particularly tiny corpora or genuinely isolated languages with no comparative reference point, that no methodology can fully overcome without major new discoveries. But the pace and sophistication of the attempt is greater right now than at any previous point in the history of linguistics, and the combination of human scholarship and computational support that cracked linear Elamite after a century of failure points toward what future breakthroughs in this field will look like when they come.